My name is Mark A. Allen. I am an economist and engineer by undergraduate training, and more recently am one of the primary developers of Life 365 version 2.0. We want to give credit to Evan Bentz and Michael Thomas for their initial work in the software. So what I'd like to do now is go through a simple example about how to use the software, or our walkabout with the software, is to run through a simple example, the sort of prototypical example where you create a baseline concrete mixture, one that doesn't have a protection strategy, and then compare it to one that has a specific corrosion protection strategy and walk through the software and see what the software gives you in terms of answers. Two main categories. One is the compare the deterministic results, or compute those, where we're going to compute the best guess number for service life, the best guess number for life cycle costs, look at some of the reports that are generated, and then quickly show you how you can grab the results that you need or that are important to you for your own reports. That's essentially the version 1.1 or 1.0 story of Life 365. That's still the same. Then we're going to go into conducting the uncertainty analysis, where we look at probabilistic service lives, probabilistic life cycle costs, and then the sensitivity to underlying constituent costs such as repairs, inflation rates, those types of things. So on the left-hand side here, when you don't have a project open yet, you see this banner screen, and then it gives you the basic set of options. What I'm going to do is go through the example where we create a new project, and then when we're done, I'll go through some of these default settings and parameters down here. There's a tab on the bottom for how you set the defaults for your construction costs and some of the other things that are going to be constant for you across projects. And then go through the online help as well. Okay, so to start a new project, you go to the upper left-hand corner, click on New Project. What it does is it creates a project for you that has two alternatives in it. And the two alternatives are really just normal mixes. So what we'll do is name these and then modify one of the mixes. So you can add a title to the project. You can put your own name in here. I'm going to put my name here. So we've got a project named. We've got our mixes. The types of structures, you can either choose a slab or wall. And here 1D means one-dimensional, where if it's a slab, you're assuming that there's essentially uniform exposure of the concrete to the chlorides, and that the chlorides will go down through a slab in a one-dimensional fashion. The other choice here is square columns or circular columns, and in this case I'm going to just select this so you can see what it looks like. Here now you can see a cross-section of what the square column looks like. In this case, you're assuming that the chlorides are exposed on all four sides and that you get ingress through this. And because of the two-dimensional nature of this ingress, you'll see different patterns of chloride exposure through the Fickian calculations. So this is a cross-section through, and you get exposure on all sides. Right now we're going to stick with a slab or wall. In this case, the chlorides are exposed to this top layer, and you're computing the amount of time it takes for the chlorides to go from this top down to the top surface of the reinforcing. And you can see on the other side, it's showing you the length of that, the distance from the top surface to those calculations, to the top surface of reinforcing. So we've got a thickness of slab that it has by default, and just for today I'm going to keep it to that. You can change it to what you like. It's got a depth to reinforcing, and then we've also included now an area of the concrete so you can get a better idea of what your real square foot costs are, or in this case square meter costs are for the concrete. And then it's showing you the total volume of concrete as well. And this is important later. There are calculations that allow you to compute the life cycle cost in terms of dollars per cubic meter of concrete. And then now you can express your chloride concentration units. That's the exposure, the external exposure to chlorides. It's the level to initiate corrosion. Those types of values, you can express those either in percent weight of concrete or kilograms per cubic meter. For now, I'm going to keep it at percent weight of concrete. Right now, our base year in our study period, we're going to look at a 75-year study period. Our analysis period is going to be 75 years. The inflation rate that the government uses as a default for government projects is 1.6%, and the real discount rate is 3.0%. And you'll see here when I hover over this, It shows you what the allowable ranges of values are. And then over here, watch this area of the screen. When I hover over these, it gives you information about what these are. But you can put in your own values and again, through the sensitivity analysis, see if your results are sensitive to changes in those values.